So it's very good to be back in Barcelona. I actually this is the only city in Europe that I've been to twice. I haven't been to that many cities, but beautiful city. Very happy to be here. I want to thank the organizers, Chus, and everybody else from the organizers of Baruco. Beautiful city, beautiful place to be, and also thanks to all of you for being here and the other speakers. So I work at Engineard on Rubinius. I started working on Rubinius late 2006 and started working with Engineard in January of 2008. And as a company, I think they've done more for Ruby and Rails than many companies have done for any language. So I'm very happy to work there. Basically, what I want to talk to you about today is this idea. When you look around at how you write code, how other people write code, not much has changed in decades. And I would like to do something about that. So if we look at, like, these are the things that we have, right? If we're going to write code, we have debuggers. We can profile our code. We can see where, what code is running where. We might look at, like, for our total code base, what the coverage is. If you use a statically typed language, then you have this little theorem prover that checks your type stuff is correct. And we have an editor, right? These things largely are unchanged for like decades. So there is one language, though, that does things a little bit differently. Smalltalk. You may have heard of it. And basically, anytime you start talking about code, someone will say, well, Smalltalk did this, right? So the fact that Smalltalk already invented everything and we're not using Smalltalk probably means that either Smalltalk didn't actually invent everything or we just sucked, right? You can decide which one of those it is. In Smalltalk, writing code is sort of a function of running code. So your system is running, and your editor is part of the system that's running. So you can like write some code and like change how your editor works. So it's a very interesting system, but the total experience of writing code is largely not that different than when you're writing in Ruby or something else. We have this editor, and our editors are basically like, we talk, there's like, Slime, is that the new big thing, the new hotness? Like TextMate was going to be for a long time, and TextMate 2 took forever, so then people actually started using Vim and Emacs again, which they've been using like decades before that. And then, so that, like, editors is just this thing that it's like a really good photographer or something, it's like not taking like a picture of something, it's just like pointing pixels here and there, it's like that level of sophistication. In language, like, so in English, this is a perfectly grammatical sentence that is absolutely meaningless, right? It means nothing. And yet you can actually sort of, if I say this board swam wistfully through the narrow sky, you can actually like sort of create some image that goes with it, but it's absolutely meaningless. It's like writing a program that type checks and everything and then just sits there and like Zed was saying, doesn't halt, right? So, our editors and the way that we write code, it's basically about the level of sophistication of a spell checker, right? And if you've ever been typing on your iPhone, right, and you have a spell checker and autocorrect, right, it works so well, right? There's whole sites dedicated to like the hilarity that ensues from like autocorrect, getting in the way. And that's about the level we're at in writing code, right? So writing code, right? Writing code, the word that we basically use is programming, right? So what are we doing when we're programming? We talk about all these things, like Zed's talk was just fantastic for me, I think, because I love to see where people start to build up this beautiful structure in the sky about how important, like he says, category theory is, or test-first development, and you start worshiping at this thing, and like he says, your brain just goes off, right? You're no longer like critically thinking. You're no longer questioning, is that really helpful? Is that something that we need? So, patterns, like there's always something new to like help you protect against some terrible thing that you probably haven't actually asked whether it's that terrible or what's going to happen if you don't do it. So nothing is wrong with any of these things, but are they what we're actually doing when we're programming? Are they the most important thing that we're doing? we hear something like this. So someone will say, good design communicates intention. And everybody like nods and like, yeah, intention. And when you look at the ordering of the concepts here, good design comes before communicates. But if we were to try to break down what those things mean, good design is this very nebulous and difficult to describe thing. But there's another word in here that I think is a lot more concrete. And then we can actually look at what makes up that word. And that's the word communicate. I think that when we talk about programming, when we talk about writing code, the most important thing that we're doing is we're communicating. And the definition here, this definition just comes from the Apple dictionary on my computer, but you can look in a big dictionary or something. It's going to be very simple. It's imparting or exchanging information. And there's a lot implicit in that definition, right? So if you're going to impart or exchange, it suggests that there's an actor. It suggests that there's somebody who's receiving. I mean, I guess you could impart information to yourself, but that's kind of hard to think about, right? Because if you didn't know it before you told yourself about it, then yeah. So there's probably two people there. When we're programming, we have the computer, we have something that's running our program, but we also have our later selves, and that's something that you could actually communicate with your later self. You come back to that code a week later and you're like, who wrote this? And you go get blame, and you're like, oh, I did. Or other programmers, other people that are going to read our code. So the idea, the fundamental sort of idea, I think that what we're doing when we're programming is we're actually communicating. That's the thing, and I didn't make this up. Kent Beck actually has a book that started out as Small Talk Best Practice Patterns, and it was rewritten as this book, Implementation Patterns. And the rumor is that he's going to write one that's more focused on Ruby instead of Java like this one. But basically, the idea is that you're communicating when you're writing software. The other thing is that the software that we write, almost every piece of software we write ends up itself being an artifact for communicating. So if you make a website, right, for booking travel, then some other person comes to the computer and they're using your website to try to communicate with the system, or if you're like sending an instant message to somebody, you're using the software to communicate, and things that system does may either enhance or impair that communication, right? Like typing, a message to your girlfriend and autocorrects and it uses the wrong word, and you're like, oh shit, that sort of thing. So again, communication is central. So if communication is central, how do we look at communication? How do we break it down? How do we figure out how we can communicate better? These are things that I've sort of just pulled together. I don't have like a source for this, but I'm sure there's people who have done studies on communication that would be helpful if you go look at them. But these are the things that I find most important for communicating. First off, being clear, which simply means not being confusing, right? Not being ambiguous. So if something is an X, then it should be an X and not be, you shouldn't have a question in your mind, well, is it an X or is it a Y, that sort of thing. That's just simple, obvious, or unambiguous. Simple, it often goes with clear, but they don't mean exactly the same thing. If you've seen Rich Hickey's talk about simple versus complex, right? In this sense, we're talking sort of that way, that it's not complicated. It's not too many things that come together. There's one thing or there's two things. And I think this particular one is very important. So is it relevant? You could be very clear and you could be, very simple, and you could be talking about politics instead of like programming languages or something like that, right? So it really needs to be relevant to be good communication. And precise, right? Which is simply this idea that if there's a distinction to be made, right? If there's a line to be drawn somewhere, that you do that as closely as you can to the concept that you're talking about. Another idea in communication is how you're doing it. Right now I'm talking to you, but I could have written this out and you could all be just sitting there reading a blog post or something, right? So the way that the message comes to you, right? The medium is a part of the communication, and it can impact whether communication is good or not. And then there's things that start to like go sort of away from all that stuff previous is a little bit mechanical, right? It doesn't necessarily involve a person. You could use those criteria for good communication and see how well two computers are talking to each other, right? Potentially. But when we get into more human factors, there's this idea of tone. Tone can have a very large impact on communication. If someone, if you walk in and you're like, hey, how's it going in the morning to your coworker, and they just grunt at you or something. I mean, they acknowledged you, the communication was pretty clear, but the tone, you're probably not going to be like, oh, by the way, I had a problem with your code, because they don't seem like they're in a good mood. So tone is something that non-verbally, I don't want to make it too like human-centered, but basically tone can affect how the message comes across. And then whether or not something is intimidating or threatening, like if the message that you want to convey is too aggressive, perhaps, then people are going to react to that in a way that they're not even dealing with your message, they're just dealing with the way that that's coming to them. But this isn't just for people either. If you watch people interact, especially people who are not particularly technical, if you watch them interact with computers, they're often very reluctant to try something because they're afraid it's going to break, and they're probably going to blame themselves if it breaks, right? If they do something and the computer fails, they're like, oh, I did that wrong. And it's not necessarily that they did anything wrong. The computer could be completely screwed up, but there's that tendency to blame themselves, so that whether something is safe or not can impact how willing someone is to try something. And then I think this is another thing that's very important for communication. Whether someone is open to what you're saying, if someone is very defensive, they're going to be thinking about every possible way to tell you that you're wrong about what you're saying instead of hearing what you're saying, right? So that's something else that's very human, but it can affect communication. And I think that that it's one of the factors of good communication that is not often appreciated, right? Like, you can just be talking. If you see two people in an argument, you're like, how much are they communicating and how much are they just sort of protecting against actually getting the message, right? So those are some things about how communication, how we can analyze communication, how we can see how good communication is. The one that's very interesting to me from the standpoint of changing how we write and run software is the idea of the programming language itself. So the choice of programming language, the programming language, and when we look at those factors of communication, the programming language itself is not just something that we're using. It's actually the medium that we're conveying meaning with, right? It's not just the arrangement of symbols. It's more than that. It's the thing that carries the communication, right? So the choice of programming language, whether it's Python or Ruby or Haskell or Clojure or something like that, is not just the syntax and the grammar, the way you have to put things together, and whether you can use a string that's immutable or a string that's mutable. It's actually the whole body that's carrying that meaning, and it's going to imply things about how well we can communicate. One of the biggest, in my experience, debates in programming, like if you talk to different people, it's like, do you use a statically typed language or a dynamically typed language, right? So the emphasis being on typed here. So here's a definition of type. It's a category of things that have common characteristics, right? But if we take a look at Ruby, where's the type in this, right? There's no type here. What we're doing is we're dynamically setting a constant. So the fact that we can set a constant at runtime instead of before, it implies runtime versus writing code time, right? Which we don't have a good word for. Authoring code, something like that. It's dynamic, but it doesn't really have anything to do with typing, right? Or this, right? The instance variable b right there, I'm defining a singleton method, so I'm adding an instance variable to this particular object. Again, it's dynamic, but it doesn't necessarily imply anything about a type. The fact that I'm changing the singleton method on this object A means that A is no longer going to be quite like other objects, even if it's of the same class. But the fact that the instance variable can be created dynamically doesn't, again, really have anything to do with types. And if I do this, right, if I create a new class at runtime, this is closer to a type, but there's not actually a class. I just really have an object that I sent a message to, right? I just asked for a new thing. The thing happened to be a class that I'm asking for a new one. So that last slide, it's a little bit of metaprogramming, right? The idea of like not the language itself, like just def, class, whatever, but the idea of sort of talking about the language that you use to define your program, right? This idea of metaprogramming is often seen as something apart, something that you can do in Ruby but you can't do in something else. It's basically, again, just sending a message to an object, right? So metaprogramming is not really that different. I think just focusing on this idea of computing values, right? By using these little objects or values, I took the word object out of there to try to keep it a little bit away from object-oriented programming. Basically just computing by having these values that you send messages to is, I think, a more important way to look at programming than getting too wrapped up in types, right? So I want to take that type out, and we're just going to talk about a dynamic language and the implications of just using a dynamic language, something that can change its form or structure over time. And we'll leave the whole typing debate to people who just want to argue, right? So my assertion is that dynamic language actually communicates better. Based on those things that we looked at before, the characteristics of good communication. If I have something like this, right, it's quite simple, right? Because each element of this, right, is relevant to it. I don't really care what type of thing X is. I only care that it has some behavior called Y, right? It's clear. There's no way to sort of confuse what X dot Y is with other parts of it. It's relevant, right? What I'm saying is I have a collection of things. I want to visit each one, and I want to ask for this particular value to be computed, whatever Y computes, right? And it works just fine if you have a heterogeneous array like this, right? It doesn't have to be all of one type. There's nothing that adding, X is integer, and only integers can, function here. There's nothing that adding that additional level of specificity really helps me understand this code any better, right? One of the things that we get sort of wrapped up in this whole statically typed versus dynamically typed thing is this idea of correctness or safety, rather. It's like, well, you want your program to crash at runtime. It's like, oh my God, what's going to happen? The program's going to crash. The confusion there is often correctness versus safety. Ruby, if it raises a no method error, it's not really any less safe, right? The computer is not going to be in a state that it can't recover from, but the program's not really correct unless what you're trying to do is raise a no method error, right? So we can have very safe programs in Ruby that are not statically typed, but they may not be correct. And you can have completely safe programs in a statically typed language, but they might not be correct. And what I'm more worried about is correctness than safety, right? Okay. So writing code, communicating, that's the central activity, right? I think what we're doing when we're writing code. What about when we run code? Like, every time you run a program, it's not necessarily the same context, I guess, right? These are different reasons why you might run your program. You might just be like in IRB or some other REPL testing stuff out. You just want to see what happens, right? Or you could actually be running all the tests for your program. The sort of feedback that you get if you're just doing some exploratory programming might be a lot different than you care about when you're testing, right? You don't necessarily want to know what particular thing ran when you're testing. You want to know, did everything pass? if it failed, if there's some failure, can I get to the code and the test very easily? When you're doing exploratory programming, you might want a lot of like output. You might want to see like the whole structure of the object that you're playing with, stuff like that, right? You might be running code in development. You might have, Rails up and it's got the great like dev mode where you change one file and you go do something and you don't have to like communicate, okay, now reload, this sort of thing. It takes care of that for you. So you're running in development. Again, you have like different output that you want, different way that you want to communicate with that. And then, it might be actually in production. Right? So that might be another way that you're writing code. Or you might actually be learning. So the difference between that exploratory and learning is that you might be following exercises. You don't know anything about this programming language. You're just beginning, and how you run the code at that point, you might want different feedback from the computer than you would get if you were just doing like deploying the program. Just go over there, run. All I want to know is that server alive, that sort of thing. So we tend to lump everything together. It's like running code. It's just like, there's no difference in how I sort of execute Ruby under all these conditions, right? I would just be like Ruby, whatever, script, and it does it. There's like no additional like context or anything. It's just like it's all running it. And I think that's something to think about. Is there a reason why we're running code and we just sort of run it all the same way? So this project that I work on, Rubinius, right? It's an implementation of Ruby. If you don't know anything about Rubinius, which I'm hoping is pretty rare, please talk to me. I'm not going to go into a lot of stuff about Rubinius. Here's 3 reasons why you should use Rubinius, or you should try using it. We have a precise garbage collector. It's a pretty good garbage collector. Might not be as good as the one in the JVM, yet, that sort of thing, but it's far better than MRI's. It's precise. We know every object that is an object. So we don't scan huge stacks of stuff saying, are you an object? I'm not sure. Okay, I'll pretend you are, maybe, that sort of thing. It's a precise garbage collector. And we typically see like 5 to 10% of time spent in garbage collection, which is more than we want, but it's still far, far lower than I think you see in MRI. We have true concurrency, or however you want to describe this. So there's no global interpreter lock, right? So if you spin up 2 threads, they can both run Ruby. If you have 2 cores, they can run it simultaneously, right, in parallel. And we have a just-in-time compiler. So the bytecode virtual machine chugs along, and at some point, your code gets hot enough, and it says, you know what, this is used a lot. Let's generate machine code directly. So we do type feedback. We sort of keep track of how everything is actually running. So these are reasons why you might want to use Rubinius. For the purpose here, I want to talk about some of the stuff that we have in Rubinius that I think we can use to build some tools that are going to help us achieve changing the way we write and run code. In Rubinius, if you go into MRI and you do def whatever, that last line where you see Rubinius compiled code, you would just get nil back, right? MRI, you define a method, and it says, okay, thank you very much, and you get nil back. In Rubinius, what you get is an actual object that represents the method or whatever computation you just defined, right? So I define this method, I get this compiled code back. If I take this code right here, right? So simple method takes an argument, generates a string. If you look at this in the Rubinius, like you can do rbx compile and get this output. If you look at this is sort of a description of the object. You can see the arguments, arity, you see the local variable and its name, you see how much stack size it actually needs. It needs 4 like slots on the stack to do this computation. I ran this at the REPL, not in the code, so it says there's 1 line that if you ran it on that little file, it would be 3 lines, and then you see the bytecode, right? So the reason that this is important is that this is a representation of your code that is faithful, like exactly what you wrote is just transformed into this other form that allows us to do a lot more analysis of it, and it's saved. It's not just like sort of hidden away somewhere. It's something you can get your hands on as an object in Rubinius. So what might we be able to do with this, right? So you have your Rails app, right? Which has a ton of Rails code, and you've got all this core library stuff in Ruby itself, stuff that you may never have looked at. You've got all this stuff running, and you have your app deployed in production, right? And you have the tests that you run before you deploy your app in production. The thing that we typically see is those are completely separate processes. There's nothing that's shared there except for the source code, right? So when you deploy, you might send the source code over there. When you're running the test, you have the source code here, but there's nothing that exists between them, right? If someone were to like look at the server, they wouldn't necessarily know anything about the test that you ran. And if you were looking at just the test output, you might not know that the thing is deployed in production. But we have something that we can use to create a link between these two things. We have those compiled methods. So everything in Ruby, every class body, every module, block, method, script, every one of those things, anything that ever runs in Ruby, we represent as that compiled code object, right? So one of the things that would be interesting to do, right, is that if in my tests, like we often use like a mock or a stub, right, and we say this thing should respond to this message. If we kept track of those things, and we have code running in production, and we say, you know what, the actual object that I see at this bit of code doesn't have this method that was there in test, that could be a problem, right? That could be something that could lead to a failure, and your code might be running fine in production, you might have no problem, but there could be a problem, and right now, how would you know that, right? There's no way to know. There's no way to actually see if something might fail tomorrow. But what if you could do an analysis of your code that's running in production and the code that you ran during testing? Or something that I think is a lot more interesting, what if you could actually associate a particular feature in your code with, a particular feature in your application with the code that provides that feature? So you get a new Rails, you start working on a new Rails project. It's not yours, you didn't start it. It's an existing project, and it's pretty big. And you go in, and they say, we need to add, OpenID to our login, sort of thing. And you're like, okay. So you go sort of read the tests, and you look a little bit at the code. You're like, I think login happens here. You expend a lot of energy to like figure out how things go. What if instead you just started up the application and you logged in, and then when you're done, you're like, show me the code. And you're able to go through and see all the code that ran. So the way that you could do this, all those compiled code objects, right? Every single one of them, what if all you could do is just start, every time one of them started running, you just put a timestamp there, right? And then later you sort based on the timestamp, and you visit every piece of code, and you see, oh, I went here first, and then I went there, then I went there, then I went there, then I went there, and you can just see like a tour of your code. Right? Or in production, if you could look at this information in production, you could see that these users interacted with our application in this way. You could associate geolocation information. You could associate time. In the morning, users tend to use this feature, and in the afternoon, they use this feature. Or you could do, sort of analysis of what sort of things are actually more important, right? Because then when you're looking at allocating developer time or resources, you can make a more informed decision than just like, oh, I think this feature is important. It gives us a basis to communicate about the application in a way that right now we have nothing. I mean, I know nothing, no other like tool that would give you this sort of information. Just the fact that we have that object, that compiled code object, that we can start associating information about how the application is running would enable us to create a feature like this. And then to sort of use this word type again, it's not, I don't want to get hung up on type, but basically anywhere in your code, right, that these values are flowing through, you can look at those values. You can see what flows through. If you have a method that is fairly general, like something like map, and you want to see, well, what sort of collections are we mapping over? You could also look at actual values that go through your code, right? And in looking at those values, you can sort of see, well, in a web application, it's kind of simple, like basically data comes in a form and it goes through, but to be able to look at where those values originate and how they tour through your code and where they come back out gives you ability to look at this data flow, right? And you can see like from the standpoint of performance, or you can see from the standpoint of like the feature map, the things like how the code is actually running, how the application is working. And then error analysis. If you have, imagine you have like an exception in production, right? And you basically assume it's something like what we looked at the other day, like nil can't be converted to a string, right? So you have this nil there. And then based on the types of objects that you've seen at that location, what if you could look at all the other locations that saw those similar types of objects, right? So if a nil caused a problem over here and all in this places over here, you also have code that sees those types of objects, not nil, mind you, but these other types of objects. You could say, well, it's possible that I could have a nil over here. So what do these different code locations have in common, right? Actually potentially giving you feedback before your application crashes. So the thing that we're missing still in Rubinius is this compiled code database. Basically, if we have a way to collect all that can be on the server, on your development machine, on one of your coworkers' development machines. If you have a way to look at all of your code, not just the source code, but as the compiled code, and link all that stuff together, we could do analysis that spans testing, development, production. So this is like a feature that we're adding to Rubinius to enable building this tool. The fact that no one has built some of this stuff on the decades, if we go back to the very beginning where we looked at those debugger profiler, the sort of things that we have, I guess that basically means it's not a trivial problem, right? So there's two huge challenges that I see in trying to build a tool like this, and this is an opportunity. If this is interesting to you, this is an opportunity to sort of think about these things. The first is information display. We're used to looking at our source code in editors, and the most advanced thing that we basically have in our editors, right, is code highlighting, right? Like an identifier is a different color than like a function identifier is a different color than a variable. That's the most sophisticated we have right now. And if you add like an IDE, then you can do like, context display. It might tell you what type. That's the most sophisticated we have. But there are dimensions to the code. Like if you imagine, looking at some Ruby code and you've got different kinds of objects that come through there. How do you represent all the kinds of objects that come through there? We go from a very flat two-dimensional display where all we've added is color to needing depth, right? So how to display this information is a big problem. Oops. And the other one is, if you've ever used a profiler tool, instruments or visual VM, any of these things, if you use this stuff, typically what you get is a view of information, right, that you have to manually go through. It's like the profile information is just this tree of methods, and you start clicking through it and see it. It's like the most primitive thing you could imagine, right? Data needs to be there to support decisions, but the data is just presented in like this sort of rough form. It's like you're looking at a raw Excel sheet, and you're like, it doesn't even have the sophistication of adding a graph so you can see a trend over time, right? So if data is there to support decisions, then how do we make the data communicate something more than just a list of things that you sort of click through, right? And if we start going into like, if we start creating tools like this, then do we start questioning some of the stuff that we're doing, right? Do we need tests? Like tests are used as a way to help us write code sometimes, right? So you write, I think it should do this, so you write a little test and then you run it and it fails. The red-green refactor thing of test-driven development can be a powerful tool for helping us explore, the problem that we're working on. But all the time that I write on a test is not code that's going to run for who's using the application, right? So there's other things that tests might do. They might prevent me from accidentally breaking something, so that's a value of the test. But in terms of like how we write code, do we need to spend all that time writing tests? I don't have an answer for that, but it's something to consider if we actually look at how we're writing code and we try to make the computer communicate better with us, right? Then how does it change something? And the reason that I picked on tests in particular is because Ruby has a good culture of testing, right? But like Zed was saying, if you sit down and pound out some code and someone's like, "Where's your test?" You're like, "I don't have any." Then they're like, that code probably can't be very good, right? Does that help us build something? Does that help us communicate better? So just a question to ponder. And finally, it's like, this is what we typically see when we communicate with, the computer. It's like I have my editor up and it sits there with this blinking cursor, right? That's the best the computer can do. That's the best we can hope for. It's like I've done all this stuff. I've run my tests. I've played around. I've done all this stuff, and the editor just sits there with this blinking cursor. In human terms, right? If you came to talk to me and I just like stared at you blankly, it wouldn't be a very good interaction, right? There wouldn't be much communication there. So, I want to leave you with that question: is this blinking cursor, this blank stare from the computer, the best that we can expect right now? What I see as sort of the goal that I'm trying to attain is this idea of insight, right? The source code is this medium of communication. We've often labored many, sometimes a single author or many authors, we've labored hard to express all this stuff, to try to communicate. And yet, when the new developer comes on the team, they sit down and they clone the repo and they, sort of start looking through the code. My experience of doing that with a lot of fairly big code bases while working on Rubinius is just that sort of feeling of weight of like, oh my God, how am I going to understand all this stuff? How am I going to read through all this stuff? It's like, before you even start reading it, you just have sort of no clue. Can we actually do something like create a deep understanding of this code base without spending hours and hours going through the code and trying to make it run and this sort of thing, right? So that's my talk. Thank you. There's more information here. This, I think, is a very interesting space, and I hope that you'll join me in sort of, seriously question, is the best we can do are these tools that we've, created 5 decades ago, and we're basically doing the same thing. Is that the best we can do? So thank you.
Do we have questions? Cool.
Hi. It seems that you're talking about dynamic type enrichment or semantic enrichment as one of the problems that you're questioning.
Yes.
And it makes me think about multi-stage programming, that there is an extension in OCaml, for instance. And if you are going to build tools that help such insights, your tools will need to make assumption on the code, which is difficult with a dynamic type.
Yes.
Thank you. Yeah, it's difficult to make assumptions on your code with such dynamic typing. So, am I understanding correctly your questioning? And is it about dynamic typing? And by extension, would adding annotation about some runtime level would help your tools to make assumption on the code? Because as a developer, you know that when you reach this stage, you can make assumption, but maybe your tools cannot. It's completely generic. So if you add type runtime levels, then your tools will be able to understand it.
Yes. No, it's an excellent question. So that's the central role of that compiled code. So sure, if you take a dynamically typed language like Ruby and all you have is a source code, as a programmer even, you go in and you look at it, you're like, what sort of thing can I do here? You start looking at the methods that are called on an object, and you're like, so it has to respond to 2s, okay, so that's one class of objects, but then it's got concat, right? And you're like, I only know concat on array, so maybe this thing can only be an array, right? But at some point, you could add some other object that responds to concat, right? So the idea is that being able to add information not just from you working on this code base, but one of your coworkers, when you ran the tests in production. Imagine if you could look at your application instead of just this bit of source code right here, but as a spectrum of the source code with the work that you've done on the application, your coworkers, when you've run the tests in production, what sort of things have happened. Imagine if you could see sort of a superimposition of all that information as you are looking at your source code, or as your coworker is looking at your source code. So it sort of takes these arbitrary boundaries that we have right now, right? You clone the repository, your coworker clones the repository, it gets deployed over there. Those things are completely separate. There's no way to communicate. If you had a way to start building up metadata about that, type information would be one of those examples of metadata in a way that as you're looking at the code, you can see all that. Or as the machine is running in production, and you've got some analysis stuff, sort of chicken, like, is everything okay here? You know, that sort of thing. That's the sort of thing that I'm envisioning.
So what you are hinting now is like some kind of distributed constraint system?
It could, distributed constraint system. Well, I mean, I wasn't thinking in terms of constraints, but yes, distributed, right? It's like our computer's network. Why does the code act like it's completely separate?
Right. Yeah. So it could be like a distributed type system, I mean, to some
Sure.
extent.
Sure, absolutely. Yep, totally. There's one up there.
Question?
Well, hi.
Hello.
Well, I got to think about languages, not just programming languages.
Yes.
Natural human language. It's a thing about me. And Zed says programming is shitting characters into a
Yes.
file. I actually think of it as talking to my computer.
Right.
How sad is that?
And how does the computer typically respond?
Fuck you.
Yeah.
That doesn't work.
Stares at you
That's
blankly,
the idea.
right? Yeah.
Yeah, well, you know what I mean. Now, that thing about everything you showed, so the theme of communication generally resonates with me. And it's also about how short is the loop,
Yes.
the feedback loop from the computer. And what you showed, the little bit that you showed in Rubini is how it responds by compiling code and the jitter and what it gives you back. I think that it would actually work very well with those ideas that Brett Victor saw
Yes.
in his
Certainly. Brett Victor's designing on
and
principle
Chris
talk,
Granger's
yeah.
light table. Have
Yes.
you looked into that?
Absolutely. I've looked at both of them.
visualizing such change would be perfect in that kind of environment.
Yes.
I think.
Yeah, and not to knock what they're doing, but I mean the fact that it's revolutionary that you basically made your REPL your editor, to me that's depressing, right? That's the best we can do. You basically have IRB sessions sort of running along with your code. I mean that's the point that they're at now.
Actually,
I think
it's
we
not-
can
yeah,
do way
that's
better
the point
than
they're at now.
Yeah.
But essentially, the vision is that at any point in time where you are in writing your code, binds all that metadata. It brings the documentation in, the feedback, the compiled code.
Yes.
And if you pull that distributed, if you can network it with
Right.
everything else, that would be.
Yeah, it would be that's where I'd like to see us go. Absolutely.
Thanks a lot. That was nice.
Thank you.
My question, more than
Where
a
am I?
question, here, over here. Hello.
Oh, there you are. Hey.
I really love your talk, but something that pursued me that at the end, you talk about how to display the information. Shouldn't it be how to engage in productive conversations with my
Absolutely.
computer?
Yeah, that's
Because
far
displaying
far better.
information
Yes.
is not like a talk. I mean,
Yeah.
you're showing me something, but I don't want information, I want to talk.
Right.
As you said, and get significant responses or
Absolutely.
even questions like, are you sure what you're doing?
Yes.
Have you noticed that graph will
Well, have-
crash
right.
eventually?
Right.
You know?
Have you used Microsoft Word? I mean, you don't really want it to say, it looks like you're writing a letter. Can I help you with that? Right? But you're right. And the display of information is just because our actual ability to communicate with the computer is mostly limited to display. But yes, why couldn't it talk to you? Why couldn't it I don't know, do other things. But yes, a much better way to say is like, how do you facilitate a conversation? I don't want that computer just blankly staring at me. Yeah, absolutely.
All right. So we have no more time for questions, but
Thank you.
Thank you, Bren.